Okay, ladies and gentlemen, this is the very last question in section 2.4, and we're looking at 2.4 part 3 on my videos. Now, this question is basically something referred to as a linear model. For those of you going on into college algebra, the 1105 course after this one, it's very important that you catch this because linear models are going to be very important for you. The same with statistics, so there's a lot of applications to them. Pay attention to the fact that E in this problem represents the life expectancy in year T of a female, and T is the, E is the life expectancy, and T is the number of years from 1990. So T is measuring the amount of time that's gone by from our beginning year. So 1990 is virtually our origin. So when I tell you in 1990 the life expectancy is 79, that would become the ordered pair 0, 79. In 1990, T is 0, and the output, which measures the life expectancy, is 79. In 1995, the life expectancy is 79.4. That would be written as the ordered pair 5, 79.4. And of course, the way I came up with 1995 is 5 years away from 1990. Therefore, T is 5. Remember, T is input. 79.4 would be output. So I have two ordered pairs from this model. To find the slope, change in output divided by the change in input. So 79.4 minus 79 divided by 5 minus 0, using the two ordered pairs above, we get 0.4 divided by 5, which is 0.08. So we've just found the slope. And actually, I've written change in y over change in x. In this problem, it would actually be change in E over change in t. So the variables mean what they represent in a particular problem. They take on a meaning. The ordered pair 0, 79, remember an important fact. Whenever the x value is 0, the y value is b. So we know that b is 79. Therefore, our model is E of t equals 0.08t, 0.08 is the slope, plus b, which is 79. So what we've just done, in not a really complicated way, is we've created a function, a linear function, which represents a model. Use this function to predict the life expectancy of a female in the year 2003. Well, remember, T is the number of years from 1990. So if I take 2003 minus 1990, I get 13. In other words, 2003 is 13 years away from 1990. When I put 13 into my function, that is 0.08 times 13 plus 79. I get the answer 80.04. And if I were to interpret that in words, that would mean that 13 years from 1990, which is the year 2003, the life expectancy of females would be 80.04 years. So what we've done here is pretty substantial. We've created a linear model, and then we've used it to make a prediction. One final comment I want to make. Linear models are constantly changing. The data is changing. The demographics are changing. So remember that a linear model is not going to be perfect forever. So all linear models have a certain life value, and after a certain year, they're no longer good. Data needs to be recollected to determine what your new model would be. Okay? All right.